Okay, today we're going to discuss the difference between speed and velocity. Okay? First things first, speed is a measure of how fast something moves through a particular distance over a definite time period. So let's write that down so you have it for your notes. Speed is a measure of how fast something moves, or slow, how fast or slow something moves through a particular distance over a definite time period. And it can be represented by a formula. And if you remember going back to density, we talked about the formula triangles. We're going to be using a ton of them during this unit, so get used to them. The formula triangle for speed is distance over time. So distance divided by time. So speed equals distance divided by time. Distance will usually be measured in meters and time in seconds. So speed, the unit for speed is going to be meters per second, generally speaking. All right? So the formula for speed equals distance over time. And that's what this big long definition is. It's saying, look, if you take the distance and divide it, the distance something traveled, and divide it by time, it's going to tell you an object's speed. Now, velocity is speed, but it has to have a direction. Okay, because velocity is a vector quantity. Now, I'm going to just write down this. Speed is a scalar quantity. Okay? And the main difference between velocity and speed is that velocity just has a direction. So you might say that an object is a measure of how fast something moves in a specific direction through a particular distance over a definite time period. Okay? So velocity is speed, in a specific direction. Okay? Know about some things we need to know about speed. Okay? First of all, you should understand that speed is how fast position changes over time. Okay? And if you cover a certain distance in a quicker time, you're going faster. Your speed will be faster. If you cover the same distance in a slower time or more time, you'll be going slower. Okay? So speed is how fast position changes over time. Okay? It could occur at different rates, like I just said. Okay? You need to memorize the speed triangle. Okay? Remember, speed, we said, speed equals distance over time in meters. Okay? So distance will generally be in meters and time in seconds. You know, you're probably most familiar with measuring distance in miles per hour. Okay? So your speed equals distance over time. But just like if you like are using our density triangles, if you knew the time and speed, the speed and time, you could calculate distance. Okay? If you knew distance and speed, you could calculate time simply by plugging the numbers in. All right. So in this example, speed will be the units for speed are going to be meters per second. Okay? Generally speaking, speed does not have direction. No specific direction. So it is a scalar quantity. It is simply measuring the magnitude of the distance you're traveling in a specific time. Okay? Now, velocity. Velocity is speed with a direction. Okay? All right. For example, a runner might be moving 4 meters per second. A car, or a car may be moving 10 meters per second left. So you have two parts to it. You have the magnitude, the size, and direction. Size, which is magnitude, if you remember. And direction. And this makes velocity a vector quantity. Or a vector measurement, if you want to call it that, because it has both size and direction. Okay? Now, this is where it gets a little bit tricky, so you got to pay attention. If you change the direction, you change your velocity. Okay, for instance, if this person is traveling 4 meters per second north and they make a left, they'll be traveling west, and their velocity will have changed, but their speed will remain the same. So if they turn and now are going 4 meters per second west, the velocity changed, but the speed stayed the same. Okay? So your speed can remain the same and your velocity can change. If you're turning, for instance, if you were a NASCAR driver and you were driving around the oval there, or let's make it a circle, okay? Something that's moving in a circle is constantly changing velocity, even if their speed may remain the same. So like an ice skater. So an ice skater that's going in a circle, okay? If their speed stays, let's say, 6 meters per second, but they're constantly turning, they're constantly changing their velocity, even though their speed remains constant. So moving in a circle at a constant speed means you are constantly changing your velocity. Okay? So you're constantly changing velocity, even if your speed remains the same, because you're always turning, so you're always changing your direction. Okay? If you have any questions about this, please jot them down, come in and ask us. We'd be happy to help you with it as you work through the notebook pages and through the labs. Okay? See you tomorrow.